Okay. Good morning.
Morning.
Morning. Okay. We're gonna go over 3.3. My plan is okay. My plan is going over 3.3 and 3.5 with you today. However, after reading your group quiz yesterday, I believe you need more practice. So only 3.3, then a little bit practice. We're gonna talk a lot about the quiz. Okay. Okay. We are moving in the trajectory. Not ideal. Not an ideal trajectory. Okay. I gotta fix that. I need to fix that. Okay. We'll talk about that a little bit. Okay, 3.3. Logarithm. Derivative of logarithm. This section is about logarithm. Okay. So you cannot talk about logarithm without mentioning exponential. They are twins. They are twins. They are inverse of each other. Okay. They are inverse of each other. One more time. Remind you again. These two are inverse of each other. Okay. And what does it mean? Okay. A little bit recall yesterday. The normal ideal of inverse function, it is inverse of y equal x if and only if x equal f of y. And y equal f of x. There. Okay. Yeah, function. Okay, so inverse is like that. And to be more specific, in this case, is the inverse between logarithm and exponential is written like this. Logarithm is maybe a of y equal x if and only if y equal a to power x. Okay. One side is logarithm from the other side exponential. Okay. Yesterday we talked about this. So what does it mean by inverse? How do we actually find inverse? First step, remember? And then we're moving on into exponential function. Again, introduction of exponential function, application of exponential function, derivative of exponential function. Okay. Today, derivative of logarithm. Okay. Here are some. Let's start with the formulas. You have some of this in the handout already. Okay, so I'm just going to copy and paste the first one, the most general one. Logarithm base a of x. If you take the derivative of this, right, it basically this one. Now try to practice right in two notation. Prime notation and Leibniz notation, right? Leibniz notation and prime notation. Okay, that basically 1 over x logarithm base a of e. But this right here, you're not going to see this in textbook. You're not going to see this anywhere. This is the original formula. And this is the one that this is the not optimized. This one is not common. The least common formula of this. There are other ways of writing this. Okay, other ways of writing this. Logarithm. Okay. Another way of writing this. Keep 1 over x. That logarithm base a of e. I can break it down into this. I can split the base. Okay. What happened there? Okay. Any two number. A, B. A and E, A, B, anything. X, Y, okay? I want to slide in the middle another base. Oh, I make a division, okay. I want to split these two. That is b here, the numerator with the b, the denominator with the a, okay. I want to slide in the middle another base. See, there you go. Okay. And in this particular case, I just did that. E right here, A down here. What's A right?
Natural one.
Natural log, which is the base? Base E. I can also do this. Because it's random. You can, as long as same base, top and bottom. Okay. Base E. Because base E is natural log. Okay, that's a property of logarithm. Okay. And what it is? How much is that? 1. So it come out to be this x ln of a. This is actually the common one. That equal 1. Okay. Why is that equal 1?
Because the base and x are the same.
The base and x are the same. So a and x there. Okay. So base e of a is 1. Okay. So don't memorize this. These are going to go to. Okay. Next one is the chain rule version of this one. Okay. So we've been studying chain rule for quite some time now, right? Can you help me write a formula of that using U? Okay. So you can technically start from here. Right. But what would be the difference? Right. This is the formula for the x term. And now if I have a U, chain rule, what does it give? What does it give me? Try that. Okay. I'll let you think about that. The next one I want you to think is about this one. Natural log. Okay, so same like this formula. Exactly this one. But base E this time. Base E this time. Okay, what does it give you? And of course, we cannot talk about, we're not going to take the derivative, put down the chain rule version of each one, right? Each formula now you have a chain rule version, right? An x and then a u. Okay, so try the u one. Okay. Okay, now somebody give me this. What will be the answer to this? Pressure?
U prime times 1 over U ln of x.
So u prime times 1 over, right?
Yeah.
Times 1. Times 1. Then I put it in the numerator, right? Times 1 over
U ln of a.
u n of a. Beautiful. Right? Basically the du, right? Basically that. Do the du over dx. Right? The chain rule. Okay. How about next one? Ln of x. That is right. Okay. Bring this one. Bring inside of this. Let's simplify that. Okay. Using this, right? Using this. 1 over x times 1. Huh? Natural log of A in this case. A in this case. E. So 1 over x times ln of E. Right? 1 over x times ln of e. Because e in this case is the base. That. Okay? And ln of e 1, therefore 1 over x. And that's also one of very easy formula to remember. Derivative of natural log. Derivative of natural log. This is the one you're going to see a lot frequently because this is the most common base. You can see this like 80% compared to this. Okay, 80%. 90% you're going to see this, which gives you this. Okay, consequently, ln of u derivative would give you huh?
1x.
Say keep going. Say again.
1x times du dx.
Okay, time du dx. But before that, what would that be? 1 over
Over u.
1 over u. Okay, that is the Leibniz version. I want to use the prime notation. I will have u prime over u. There. This thing is u prime times 1 right there. Okay. In fact, you only have 3 formula in here, maybe 4. But the most important one are these 2 down here. Okay, if they ask, then we will mostly ask. Okay, the natural log, the derivative of logarithm, natural log, and the derivative of chain rule version. Okay, down there, you see it right away. Okay. Now you have the formula. Try that. Y prime. Pick a correct formula and apply to this. ln of x or ln of u. Okay, so okay.
I'm like past the point where I started.
You're just man.
I'm good at this one. That'll be a little
Hey, did you get a refund?
Hmm?
Did you get a refund?
Four.
Absolutely.
No.
Okay. I see ln, right? And we'll be looking at either this one or this one. Which one do I look at?
You.
U one.
Hell yeah.
Okay. U in this case is 3x to the power 5 minus 6. So according to the formula, 3x to the power 5 minus 6 stay in the denominator. Right? U down there. Okay, so U prime right here, U down here, U prime over U. U prime of this one will be 15x to the 4 minus 0, right? There you go. And some of you got this correctly, but if you want to simplify it further, I see that the 15, that 3, that 6, all of them are multiple of 3. So 5, no, 4, 1, and 2. Okay, so that's how it goes. Okay, another one. So U prime, I just use different notation, right? U prime could be Z, could be T, could be G, just a variable, just an alphabet. One more time, same idea. U prime over U. Okay, U prime over U. U prime over U. So put this one down first. Right. Prime of that. But did you see something? That a logarithmic function. Good. This is an old logarithmic function. Inside is just an element. The variable inside is cosine. But the model function of this one is the big one outside. The model function is logarithmic function. Somehow the derivative of that one look like a tangent. Okay. That is one of the connection. There is a connection between logarithm, exponential, and trig. Okay, we're gonna study that eventually. Okay, but just let's give you a glimpse. They have connection. Okay, logarithm, exponential. Even though they look like this, one is like exponential. Yesterday we studied logarithm. If it is like this, right? Logarithm. There. Somehow you can translate to something like that. Just translate to something like that. Okay. All right. That is advanced. Very advanced. Okay. Logarithm differentiation. Oh, I think, did I talk about the graph of logarithm? Did I talk about it? Okay, just, you should know. Okay, if I haven't, let me give you just the plot of logarithm. Okay. Let's say this is e to power x, right? E to power x. E 2.7 something, right? 2 power x is squeezed between 3 to power x and 2 to power x. We talked about that yesterday. And we know that the inverse of this one, okay, if this one is f of x, then the inverse is natural log. Okay, natural log. And we know that the inverse, the internal plotting, it's just a reflection of this one. Whatever on this side reflect over the y equal x. This diagonal line. Right. Y equal x. That diagonal line. How do you, yesterday we draw a few of them, right? How do you draw an inverse function? You have this one, original one. Just reflect it down here. And if you reflect it correctly, this is ln of x. That's ln of x. Okay. How much? 1. What does it mean? Okay, the 1 over here, that means e to power 0 equal 1, right? Right? E to power 0 equal 1. Look, 0 right here, 1. What does it mean? ln of this, remember this is x-axis. So this means ln of 1 equal 0. That is also a property. ln, in other words, logarithm, whatever the base, logarithm of 1, no matter the base, equals 0 right away. Look. Yesterday I gave you an example about the chicken, right? Time thing. If that is t, time. If that is time, then if we are here right now, right? This is the past, that is the future, right? And what do you say about this? We right here. If you explain that expression for a non-mathematical audience, how do you say that in a full sentence? That is actually eventually your job. This expression. Let's bring up a chicken. Bring back a chicken. Then how do you say that? This is the time. This is the time. Right now, right here. If this is time, what does this axis represent? Number of chicken. And when time is 0, and when time is 0, in a plain English, you don't say, okay, you only speak in front of an audience, you say, when the time is 0, how do you say that? In the beginning. Okay. One chicken. Right. Okay. In the beginning, okay, in the beginning, that is the time, the one on the right side. In the beginning, that is one chicken. Okay. I think I should. I never give this kind of problem, but eventually I think it's important that I ask you to write down a sentence, explain these things. Okay. Should be a good example. Okay, just look at some expression, explain by your own words. Eventually that is what you do. You look at something, you tell the story. Okay. I believe in math, one of my math, 4 something, 485, I remember. Back in the day, professor gave me only a plot. Okay, that was my midterm. Just a plot. I literally had to write a whole essay. We had to write a whole essay, like a page. Okay, that plot, what does it tell? Literally, and that is one of the very good classes, I think. Okay, I took just a plot of, I believe that was of the stock market from throughout 2 years, 8 quarters, just stock market, some company. Okay, each person get a different companies. Within an hour, how do you explain that to a non-major audience? Sitting in the front of the audience, you want to call in for investment. You want to convince them to invest in your company. Okay, how do you explain that? Convince them. Okay, all right. And I failed that one technically. Yeah. Oh, that exam I failed. Yeah, that exam I failed. No, be honest. Yeah, he was top rater. I didn't fail because I didn't understand math. I failed because I couldn't convince him. Every information I explained correctly, I get half, let's say 10 points. The other 5 points is convincing part. You understand the math, but you cannot convince, you cannot tell the audience so that they understand. It's meaningless. Right. The other half is even more important. English is one thing, math is one thing. The other half is the English side. Okay, if you cannot convince the audience, no matter how much you understand, it is useless. It's only meaningful to you. Okay, yeah. Moving on. Logarithm differentiation. Okay, we're gonna apply. Okay, why do we need to study derivative of logarithm? Yes, we want to turn back the time about the clock. There's another very powerful application of logarithm. Okay, it's called logarithm differentiation. Okay, another term right here. Logarithm differentiation. A couple of weeks ago, we learned in 2.7, we learned implicit differentiation, right? Where we take derivative of something is implicit function. You cannot isolate the y. You stuck with something like this. You solve for y, you're gonna have plus and minus, square root, blah blah blah, ugly. Okay, but you still want to take the derivative of that thing. Implicit differentiation have you. Okay, today we're gonna learn logarithm differentiation, which used to differentiate, yes, take the derivative of a complicated function, much complicated than this. And I don't think I need to explain to you how complicated this one is. Right? That one. Okay. That one. We're going to take the derivative of that one using logarithm by breaking it down. The idea is break it down into chunk. It's one big chunk right now. Okay? Entangle. Mess up, compile it into one function. Now we're going to break it out using logarithm, but I let you, okay, I give you a moment to think. Maybe 30 seconds. If you don't have logarithm, you don't have logarithm. How do you take the derivative of that? Okay. You can. First of all, don't say you can't. Like, you can. At least say, yes, you can. It take you a long time. Usually, probably take you 5-10 minutes. This one take you half an hour, No matter what, I believe you can. Okay, don't say you can't. Okay. Just pose the rules. Product rule here, power rule here, power rule here, chain rule inside. Chain rule inside, power will go down, okay, and so on. Okay, just be careful. It'll take you around an hour. Right. It's doable. It's doable. It's not that, but it's tedious. Then, how do we do this? Because if I ask you to do this in an hour and they pay me for an hour, okay, 100 something, they pay me for an hour just to ask you to do this, okay, they're gonna fire me on the next day. So we're gonna think of something else, right? Right, we're gonna think of something else. Okay, if I want easy money, I just give this to you. You're gonna sit there for an hour, wait for you to do that. But no, use logarithm. What do? Don't take derivative right away. Yes, the job is to find this thing. But don't think about that. Simplify this one first. Simplify this chunk. Break it down. Recall yesterday, there are some property to break something out. Break something out using logarithm. These two. What do I have? Right? You have a logarithm of one thing. We can break into two logarithms. If you have a product, you can split that into an addition or summation. Still a y. There. Okay, you have that. So every time I see a product, I see a division, I can do that. I see product here, I see product here, I see product here, I see a division over there. I'm gonna apply that. But in order to apply that, I need this thing. Right? X times y is not x equal y. I cannot just blindly do that. I need this, I need this. Then what do? Yesterday, another technique. If we don't have logarithm, then we brute forces. We use the word correct is we don't multiply by logarithm, we apply logarithm. Okay. Okay, put it there. Okay, you're gonna apply logarithm both sides. I put the letter L first. If you apply logarithm, you're gonna have to pick a base. You have to pick a base. You have to pick a base. Some not base, whatever base. That base is your choice, to be honest. Right? You can pick any number. If you can pick any number, which number would you pick?
Okay.
Huh?
Okay.
Better than that. E. E. Remember, we have formula. Eventually we will take derivative. Eventually we will take derivative. Which one in the logarithm? Both that has the easiest derivative, the natural log. And it isn't even easier to write, right? LN better than right there. LOG, right? Okay, left hand side dividend. Dividend. Right hand side now is in here. Okay, I want you to try to expand this one as much as possible. This, subtract this whole thing, right? And then right here is a product. You can split into addition, 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 and so on. Okay. So ln of y equal ln of something, subtract something, ln of something else. Okay, I let you fill in the blank. Ln of y equal ln of something plus ln of something else minus, and so on. Okay. I let you fill in the blank. Think about that. Using these two. Take your time. Take your time. Take your time. When you're done. be surprised with the answer. Logarithmic base a of x over y, right? Equals to a of x, which is the numerator. Subtract root of the denominator. Okay, keep breaking as much as possible. It should be the minus sign. Okay. So, numerator, okay, according to this, it's just a numerator right here and the denominator, right? Numerator, denominator. So numerator, the yellow. Don't care about the format. Just follow the formula. Exactly the formula. The denominator. The green or the blue, I don't know what is this color. Okay. Tilt. Tilt, right? There. So the denominator there. Numerator here. Okay. Right here, look for the product. So I can break into the addition. The product that I'm looking at is the between the x10 something, right? That dot right there. That dot right there give you this plus. That dot give you this plus. Okay. And split into two logarithms with the same base. That is the ln. Okay. Okay, so split that. That means this one go here, this one go here. Okay. So that means I have maybe blue. Okay, that x to power 10 and then 5. We never do math with something like that, right? Right? Whenever we see the root, what would be your first instinct? Convert to the exponent, which is 10 over 5. That would be 2. Look fancy. Complicated. Just 10 over 5. That's 2. This one?
Like a genius.
There over there. Okay. I repeat the process with these three. But this time we have 3 things multiply, not 2. That number 2. If you read it out, usually how do you know where's the multiply or division? You read it in your mind. Negative 2 times. That's the first thing. And this to the third times sine x, right? So that I have 2 multiplication. One right here, another one right here. So I'm going to split into 3 logarithms. Natural log. Split into 3. The first one is negative 2. The second one is x cubed plus 5q. The third one is sine of x. Okay. However, I should put the plus sign, right? This is product. You should have plus here. But before all of this, there is subtraction, right? This one stronger than all of this, right? This one gonna be really inside, minus this, minus this, minus this, minus. Okay. In other words, FOIL the minus inside. FOIL the minus inside. That's how you get the minus. Okay. Moving forward. We're almost there. Okay. At this stage, you technically can take the derivative. If you take the derivative on the left hand side, I'm going to give you something. We're going to talk about that in a little bit. But look at the right hand side at this stage compared to the original problem over there. Can you do the derivative each one of them? Right? Each one of them is ln of u prime. Okay, can you tell me right away the answer to this? 2x over x squared. U prime will be u. 2x over x squared. So on, right? 0. That leaves a real constant. 0. Or maybe this one. Cotangent. Cosine over sine. Cotangent. There. You can do it much quicker than the other one. But there's something else we can still do to reduce the work. Each one of this is ln, right? But there is another rule in the logarithm. This rule. I use ln now, ln of x to power n equal and ln of x. Power rule. If you have a power inside, you can throw that power to the front. That power I'm talking about is that number 2, that's 3 over 2, that's 3. Bring it to the front. So ln of y 2 ln of x plus 3 over 2 ln of x squared minus 4 minus ln of negative 2. That shouldn't be negative, to be honest. I'm going to change. Next semester, I'm going to change that to positive. Okay. 3 ln of x cubed plus 5 minus ln of psi x. Okay. The derivative is even easier, right? 1 over x. Chain rule, you don't have to do the chain rule for this one. You don't have to do the power rule for this one. When you do the u prime, this version, u prime of this one, you have to do 3 over 2 and then 3 over 2 minus 1, right? You don't have to do that. This one, what do you get? The answer to this. 2x over
X squared minus 4.
There you go. See, easier, a little bit easier. Right here, you don't have to do 3, and then this, and then 3 minus 1, right? No. Now you just have 3x squared over. Okay. So now you're ready to take the derivative. But how about the derivative of the left-hand side? That answers the question. So right-hand side technically done. Left-hand side. dy over dx in there, but something else. Something else. D over dx. Okay, let's count this. Y squared. 2y. Yes, 2y. You apply 2y to this, right? Y, and you have 1, right? In other words, you have this. Okay. Okay. ln of x, not y. 1 over x. ln of y, 1 over y. 1 over y only? 1 over y, dy over dx. Okay. When you have this, okay, let's say you're able to take the derivative of this right hand side. Final step would be multiply by y. Done. Okay, so let's see how you take the derivative of this. Go. This is a few times. Okay. Also, you get the answer. Remember, this is 0. And then multiply both sides by y. Finish. Done. Okay, one term at a time. Okay. Give it to me, anyone? Okay, first term. 2 over x. Second term. 2 over x. X squared minus 4. Third term. 0. Fourth term.
3x over x cubed plus 5.
Last term. Cotangent. Okay, so I'm gonna make next step. I'm gonna put cotangent. Okay. For those of you still trying to get it. Okay. Last step. Remember, this is our question. The question actually is. Last step. Simple, right? Multiply both sides by y. dy over dx equal y times, now I'm going to simplify as much as possible, 2 over x. I see 2 here, 2 down there, right? So plus 3x over x squared plus minus 4. Okay, minus 0, doesn't matter. Minus 3 times 3, 9x squared over x cubed plus 5 minus cotangent of x. That's basically y prime, right? Doesn't take 1 hour, right? Doesn't take 1 hour. You see how powerful logarithm is? That's the beauty of logarithm. Logarithm have you break out a big function like that into small one, divide and conquer. Alright. Separate it out. Take the derivative term by term. Multiply by 1. Any question? Good. Okay. Derivative of exponential function. Okay. Actually, this one I gave it to you last time. Yesterday, e to power x is a to power x. Okay. A to power x is a to power x times ln of a. Okay. Then you have the chain rule version. E to power u times u prime. A to power u. Actually, I missed the derivative. A to power u times ln of a times u prime. There you go. More than 90%. Again, same like the logarithm. I focus on the natural log. Okay, if you get a natural log, you get the everything else. So when these problem pop up, most of the time you're gonna see these. Okay. If the logarithm pop up, most of the time you're gonna